everyone, welcome to Earth and Life Science subject. So we're going to tackle an origin and structure of the Earth. So we are going to study different origins, hypotheses, theories. Now, universe in the solar system. So let's talk about age. Edad, age, yeah. It's not like ikaw lang ang may age. Even the universe in the solar system have age. The universe is at least 13.8 billion. Take note for that. 13.8 billion of years old. And the Earth or solar system is at least 4.5 to 4.6 billions of years old. Take note for that age. Next. So this is the solar system, or and the universe can be seen like this is just a diagram. The Earth is part of the solar system. We have the inner terrestrial planets, 3, and Earth is also known as the third rock from the Sun because third rock man, because Earth is not a gaseous planet, it is terrestrial, it is made of rock. That is called the third rock from the Sun. The solar system is part of the Milky Way galaxy. Note the Sun, or the solar system is the outer limit, not at the center. As you can see in this koan, wala siya sa center in this diagram, right? So it is the observation in the galactic core, and this can be the cameras in the universe or in the outer space. This is the view of the universe from that, yeah. So now, an explanation of the origin of the universe should be consistent with all the information about its composition, structure, accelerating expansion, cosmic microwave, background radiation, among others. Now, the question is, nga nung nakahibaw man sila, giun sa kanila? Right? Yeah, like, we have a lot of questions in mind. Why have the, nga nung nakahibaw man sila? So, let's go to the structure, composition of age of the universe. So, universe currently is comprised of space and time and all matter and energy in it. Nga nang nakaibaw sila nga naay energy. It's because they actually use particular equipment that reads cosmic radiation. The frequency has been read already, and they come out with that many hypotheses. So, it is made of 4.6% baryonic matter or ordinary matter consisting of protons. Okay, by the way, take note for the relevant vocabulary from the module. Consisting of protons, electrons, and neutrons, atoms, planets, galaxies, and other bodies. 24% cold dark matter. This is in the matter that is gravity but does not emit light. And the 71.4% dark energy, a source of anti-gravity. So the gravity in the Earth is not part of that dark energy, but there are only 71.4% dark energy in the universe, like that. So dark matter can explain what may be holding galaxies together for the reason that the low total mass is insufficient for gravity alone to do so, while dark energy can explain the observed accelerating expansion of the universe. Kung saan na nag-expand siya, it's because the dark matter, it is an anti-gravity, meaning the gravity, katong dili anti-gravity, wala siya capacity to hold all the matters in the universe, or even it's just in a specific galaxy. That's why the universe is still expanding. That's how they analyze that. So hydrogen, helium, and lithium are the 3 most abundant elements having the lowest mass ng hydrogen. These are the first elements to be formed in the Big Bang model of the universe, of the origin of the universe. Naunsa pagkahimo ning hydrogen, helium, and lithium? It is from the process that we so-called nucleosynthesis. Take note for that, nucleosynthesis. This is the formation of elements from those particles, subatomic particles, protons, electrons, and neutrons. But merely protons and electrons are abundant in the universe. That's why these elements are formed because of the process nucleosynthesis. Okay. We are going to tackle that nucleosynthesis when you are in grade 12, your next science subject. So stars are the building block of galaxies. They're born out of clouds of gas and dust. That's why they twinkling. Yeah, and instabilities within the clouds eventually results into gravitational collapse, rotation, heating up, and transformation into protostar, hot core, future star as thermonuclear reactions inset. So there are reactions happened in stars. So the star's energy comes from the combining light elements into heavier elements by fusion, nuclear burning, and that is also part of nucleosynthesis. Small stars like the sun. Take note, sun is just part of small stars. How about supernova? How about those other big stars? No? Cannot be seen here from the Earth. So each burning is the nuclear fusion of 4 hydrogen nuclear protons into helium nucleus, 2 protons and 2 neutrons. This can be explained in your next subject. Kung mag-grade 12 na. So stellar interiors are like furnaces where elements are synthesized or combined or fused together. Most stars, such as the sun, belongs to the so-called main sequence stars. So the other stars are in the other sequence na sila. Main sequence ang sun na belong. In the course of the star, hydrogen atoms are fused through thermonuclear reactions to make helium atoms. That's why di na sila muunlod mo nang naaragi ko ng pabilin ang sun. They are composed mainly by, again, what element? Hydrogen atoms. So massive main sequence stars burn up their hydrogen faster than smaller stars. So stars like our sun burn up hydrogen in about 10 billion years. Wow, okay? 10 billion years. Nga na ang atong star. Okay, take note, sun is a star. So for the birth, evolution, and death and rebirth of stars, syempre na sila yung rebirth. Okay. Pero yung man ang nucleosynthesis siya mag-process as long as there is reactions in the outer space or in the universe. So the remaining dust and gas may end up as they are the planets, asteroids, or other bodies in accompanying planetary system. Because planets are not yet planets before, because there are many hypotheses why or how planets are being formed. Okay? So a galaxy is a cluster of billion of stars. Pininjo ipon. Pero di ko kaihap kay billion bitaw. And clusters of galaxies form superclusters. In between the clusters is practically an empty space. So clusters, between the clusters, empty space. So, walay atom. This organization of matter in the universe suggests that it's ended clumpy and at a certain scale. But at the large scale, it appears homogeneous and isotropic. So based on recent data, the universe is 13.8 billion years old. Take note, for the age of the universe, the diameter of the universe is possibly infinite. Nganong infinite? Because it is still expanding. But should be at least 91 billion years. At least lang ha, 91 billion light years. 1 light year is equivalent to 9.4607 times 10 raised to 12 na siya kilometers. So its density is 4.5 times 10 raised to so na siya. So expanding universe. So in 1929, Edwin Hubble announced his significant discovery of the redshift and its interpretation that galaxies are moving away from each other, hence the evidence for an expanding universe such as predicted by Einstein's theory of general relativity. So in Einstein's theory of general relativity, there are postulates stated there that some impossible events can be possible. He observed that spectral lines of starlight need to pass through a prism or shifted toward the red part of the electromagnetic spectrum toward the band of lower frequency, thus the inference that the star or galaxy must be moving away from us. It means that the frequency of a certain in the electromagnetic spectrum, the frequency is still moving and is still expanding from lower to higher frequency. That's why we're going to test, I don't know what equipment they're using, but in their data, they can observe that the galaxies are moving towards each other. So redshift, just like this. Oh, look at the shift of the lines. Balikon. From here, they're like moving from each other, and look at the gap. It's getting away from each other, it's getting longer, larger from each other. Okay? So look at the positions. There is a difference. And that shifts can explain why the universe or the galaxies are moving away from each other, and the universe is still expanding till now. So cosmic microwave background, the CMB, there is a pervasive CMB in the universe. It is an accidental discovery by Arno Penzias and Robert Woodrow Wilson. Earned them, nakadaog sila. It's because, kung naga ni Nobel Prize, like, if you invented a specific hypothesis or an output or an invention, all of the scientists are going to test your hypothesis, and they're going to believe in that theory, or can that be an explanation, because science is more about explanation. Then they can be evaluated in that process. It can be observed as a strikingly uniform faint glow in the microwave band coming off from the direction of black body radiation with an average temperature about 2.7 degrees above absolute zero. So this is like this. Kung ilang makita sa cosmic microwave background of the universe. Okay? So now let's go for the origin of the universe. So may mga sulti-sulti, so may kinaunhan good sa universe. So non-scientific thought is ancient Egyptians believed in many gods and myths which narrate that the world arose from an infinite sea at first. Dagat pa daw siya at the first rising of the sun. Mukha na kinaunhan sa universe. Another, the Cuba people of the Central Africa tell the story of the creator of God, Bumba or Mumbumbo. Following the dark and water-covered earth, still pare-pareha siya sa ancient Egyptians nga. Water-covered kay sea manggaban sa Egyptians, and feel instance stomach pain po nagila, and then vomited the stars, sun, and the moon. So, ang God kuno, mura kuno, nag-vomit lang siya. Moto, na yung universe. In India po, gods gonna sacrifice Purusha, the primal man whose head, feet, eyes, and mind became the sky, earth, sun, and moon respectively. Non-scientific ha, mga tuo lang sa India na siya. Kinsa nga God, or ang God, ilang gi-sacrifice si Purusha. Next, the monotheistic religions of Judaism, Christianity, and Islam claim that the supreme being in the universe, including man and other living organisms. So, that is in the Bible, from in the beginning, just like that. Now we have here, this is part of the scientific thought, steady state model. This discredited steady state, nga nang gidiscredit ni siya. It was proposed by Bondi and Gold and by Hoyle. It maintains that the new matter is created as the universe expands, thereby maintaining its density. Nag-expand daw ang universe, but the density remains constant. How can it be? One ang ilang statement. So its prediction led to test and its eventual rejection the discovery, the cosmic microwave background. Because for the CMB, ang ilang statement ito is that the density of the universe is changing. So, mo nang disregard ang ilang model. Next, for the Big Bang theory, this theory has been mostly kanang gituuhan ni siya sa kasagaran sa tanan, this Big Bang theory, and it's very famous in most books. So as the currently accepted na siya nga theory of the origin and the evolution of the universe postulates. So this theory mainly siya ang naghatag sa age of the universe, which is 13.8 billion years old. The universe expanded from a tiny, dense, hot mass to its present size and much colder state. So there is a change of a temperature in which the cooling and heating of the dense, tiny, hot mass triggered the bombardment or the explosion of that tiny mass. Bang! That's why it's called Big Bang, because there is explosion. So there are generally two ideas, the general relativity and cosmological principle. In Einstein's general theory of relativity, gravity is thought of as a distortion of space-time and normally described as a gravitational field, and so on and so forth, and you can keep on reading it. So mainly on two ideas. The Big Bang theory has withstood the test of expansion. The redshift the abundance of hydrogen, helium, and lithium, the nucleus synthesis process, and the uniformly persuasive CMB radiation, the remnant heat from the bang. Bang. That's why they can test, walang na-test nila ang cosmic radiation. It's because after the bang, pak, frequency na, basa na yun nila. Okay, so you can proceed to the next video.